Okay, so now we're going to move on to the next topic, which is electric circuit wiring at our houses. So this is the wiring process or the procedure or the setup of the wiring in each of our houses, or the lines from which the electricity reaches each and every one of our houses. Okay, so it says that we receive electric power through a main supply, which it could be either from the overhead poles that you might have seen, those huge Eiffel Tower looking poles. That poles may be bringing the electricity, the main electricity into your house, or it could also be through underground cables. Okay, these are the two methods. It could be through overhead power lines or through underground cables. Okay, then all of the wires are given certain colors so that whenever the electrician comes and he has to repair something, he knows which wire is for which purpose. So the red insulated wire, by insulation we mean if this is the copper wire, then there is one layer of plastic or some other material, insulating material, that is coated on it to give it a specific color. Okay, and that is also coated so that if even if two different wires that are not supposed to come in contact, they come in contact with each other, their insulation parts come in contact and not the actual conducting wire like the copper part of it. Okay, why the copper part of it can't come in contact, we are going to study in a bit. But just so the insulation, even if the insulation comes in contact, the insulator does not let any electricity pass, so the electricity of the two wires would not be able to meet, so there won't be any shock produced. Okay, so the red insulation is for the live wire, which is known as positive also. These are the alternated names for them. The black insulation is the neutral wire or the negative. You can think of this as, say, the positive and negative of a battery. This is to maintain a potential difference. There is always a potential difference between the positive and the negative terminals of the battery, right? That is why the current flows. So similarly, there is a potential difference of 220 volts. This is the standard potential difference in India that is maintained between the live wire, which is red colored, and the neutral wire, which is black colored. Then we have an earth wire, which is basically used as an insulation. Basically, any appliance that uses a huge amount of current, say your refrigerator, it uses a huge amount of current. Okay, so, if in any case there is some kind of an electric current leakage, which could be due to any reason. So, if there is even a slight amount of leakage, the amount of current is so huge that anyone could actually die from that shock they receive from that current. So, just so that no one gets hurt due to that fatal shock, there is this earth wire that is used. So, what does this earth wire do? It is connected to that appliance which takes a lot of electricity, say the refrigerator, and it is connected to a metal plate which is deep inside the surface of the earth. So, say some excess current is generated, which if some human comes in contact with, it can be fatal. So, that earth wire takes that current and it earths. This process is known as earthing. Earthing is the process of taking unduly high charges or current generated into the earth so that no one gets hurt. So what do they do? They basically take that extra current or the extra charge and they conduct it and take it deep into the earth. And we know the earth is so big and it is electrically neutral. So even if that much amount of electricity comes into the earth's surface, no issue is going to happen. There is nothing that is going to be affected, but that person can be saved from the shock. So that is the use of the earth wire, which is used for earthing, and it is used in a green color. Okay, and it is connected to a metal plate deep in the earth near the house that I just told you. So these are the wires. Okay, great. Let's move on. Now the schematic diagram of the common domestic circuit. So this is actually the process that is followed, or how the electricity actually reaches from the main house, electricity house, to your homes. So here the current is supplied from the main powerhouse. Okay, so what happens here? This is the main board fuse, which means this is the board fuse used by the electricity board. Why is the fuse used? We have already studied the purpose of the fuse. What is it? It is, the fuse is basically used so that if any unduly high current is generated at a split second due to whatever reason, it doesn't go and damage the appliances. What does the fuse do? What does a fuse do? As soon as it detects a higher current than the appliances can take, the fuse basically melts and it breaks the circuit so that the current cannot flow into the appliances. Okay. So the current comes from here. We know there is one live wire and one neutral wire. Here the neutral wire is white so that you can see it because the background is black. If the neutral wire was made black, you won't be able to see it. But just remember that this line, this white line, this one, I'll just outline it. This is not actually white, but this is black because this is the neutral wire. And I told you that a potential difference of 220 volts is kept between the live and the neutral wire in India at standard. So this is the 220 volt that is shown here to you that I just circled. Okay, right here. I hope you can see this 220 volts written. Okay. So what happens? This electricity enters from the main fuse board. It enters the meter in your apartments, and this enters next the distribution box of the switches or the meter that is in your house. You must have seen that you sometimes put the meter down when there is like a short circuit, or the meter goes down automatically if there is a short circuit. You must have heard like this, right? So go ask your parents and look at the meter board in your house, and you will actually see many switches there. So what does those switches do? So here it's written main switches and fuses. What do those switches and fuses do? Those are the main switches for the different appliances all over your house, and they all have individual fuses so that if there is a spike in current in even one of those, just though that fuse melts so that the whole circuit isn't affected, just that appliance which could have been affected by that unduly high current is saved. Okay, so this is the distribution box. From here, what happens? From distribution box, there are basically two types of switches where to which the electricity goes. One is the 15 ampere switch and one is the 5 ampere switch. This 15 ampere circuit or switch. Okay. So think about this. If there is one type of circuit which it needs high amount of current and another type of circuit which needs lower amount of current, which type of appliances would be connected to this 15 ampere circuit? Would it be appliances which would be like very small, minute appliances like a tube light, a fan, or would it be heavy appliances like refrigerators, like your geysers, or like your air conditioners? It would be obviously heavy appliances, heavy duty appliances, right? So these 15 ampere circuits are actually for, say, your geysers, fridge, right? These are very heavy duty appliances, and the 5 ampere ones are for your bulbs and your fans, which are not so heavy duty. Okay, and you can see here the live wire, which is the red wire, and the black wire, which is here white, which is the neutral wire, have a 220 volt potential difference, and each of these appliances are connected in series or in parallel. They have the same starting and ending point, right? Look, the starting and ending point are finally connected to these points A and B. So finally, all of these appliances are connected across AB. So they are actually in parallel. Why are they connected in parallel? You can be asked this question also. Why are the appliances connected in parallel? Because if the appliances are connected in series, then the same current flows through it, and more importantly, if one appliance goes bad, the circuit breaks and even the next appliance can't get any electricity. But here, if this appliance, say this appliance goes bad, right? Say this appliance goes bad, okay? It is, for some reason, it has some defect in it and it is not a part of the circuit anymore, or it is defective and it goes bad. So, this would not affect the current going into the other two appliances. Why? Because the current will not flow here, but the current has this path to flow still, right? That is why we connect it in parallel, so that even if one appliance is affected or one appliance is not working, all the other appliances are not affected by it. And then you can see that each appliance is connected to the green color wire, which was the earth wire, which is basically grounded, so that if there is any current leakage in any of the appliances, it goes straight into the surface of the earth and it doesn't harm anyone. Okay. So I hope it is clear to you how actually the current from the main board reaches your house. All these wires, the live wire, the red one, neutral wire, the black one, the earth wire, the green one, and how they are connected in parallel, where the fuses are, where how the switch at the meter box in your house, how it divided into two circuits, 15 ampere and 5 ampere, depending upon the power rating or how heavy that appliance is. Okay, let's move on. Okay, so the next thing is the electrical fuse. So this is something that you've already studied about, so you would know about this. So the fuse is an electrical safety device. Basically, you know that the fuse melts when there is an unduly means not planned for or unwanted rise in the current, right? It operates to provide over current protection to an electrical circuit so that no appliance is damaged, right? Any appliance, if it gets more current than it is actually made for, it can be damaged by that current. So the fuse is used in series, right? If the fuse is used in parallel, we already studied about it. If the fuse is used in parallel, the current will still flow through that appliance and it will still harm it. That the electrical fuse, it has to be connected in series. Okay, I hope the logic behind that is clear to you. And I had already told you that this fuse, it has a low melting point and it melts as soon as a high current comes through it. Okay. So let me just show you a quick video which is going to make it more clear to you what exactly the fuse does and how it protects the circuit. Okay, it's a very short video. So here in this you will see a quick red flash, which means an increase in the current, and see what the fuse does to protect it. Did you see what happened? That fuse basically melted and it fell down when the current increased. So when it melts and it falls down, it breaks the circuit so that the high current doesn't pass through the appliance and it protects the appliance basically. Okay, let's move on. Okay, now let's move on to the next topic that we have to do. So the next topic is overloading and short circuiting. So let's read here. Okay. So it says that when the live wire, which was the red colored wire, and the neutral wire, which was the black colored wire, this was also known as the positive and this was known as the negative, right? When they come in direct contact. Now, do you remember I had told you that the red coloring is actually the insulation. That means that copper wire or the conducting wire is insulated, or is it? It is covered in a material that does not conduct electricity, so that even if two wires like the live wire and the neutral wire come in contact with each other, if they have their insulations on, nothing will happen. But if the live wire and the neutral wire, they're supposed to be very far apart. They're supposed to have a 220-volt potential difference between them. But if because of any reasons they come in contact, then there is a very, very huge hike in the current. So let's read. This says that when the insulation of the wires is damaged, there is a fault in the appliance. So when the insulation is damaged, the live and neutral wire can come in contact, right? Because the insulation is damaged or it might be like worn away, so the wire inside is exposed and that exposed wire can come in contact with the other wire, like the live wire can come in contact with the neutral wire and the hike in the current can happen. So when this happens, overloading is the process that can occur when the live and the neutral wire come in contact with each other, and in such a situation the current in the circuit abruptly increases, and this process is known as short circuiting. So the short circuiting is basically the process of current increases suddenly. This is the process of a short circuit. Okay, and why that happens? Because of the damage in the insulation and the live wire and neutral wire coming in contact, which is overloading. And overloading can also occur due to accidental hike in the supply voltage. Okay, that could be due to any reasons at the meter house. That can be any problem. That is not something that we can control. Okay, so these are two phenomena that you need to know about: overloading and short circuiting. Okay, let's move on. So preventive measures to prevent overloading and short circuiting, because it can actually damage our appliances. So one thing is, we can unplug the electronic appliances when we aren't using them. We are always told that, even as kids, we are told by our parents, when you're not using a charger, switch it off, right? So that in no case does it draw an unduly high current and get damaged. The second point is, keep electrical cords away from sources of heat and water, so that they do not get in touch with that water and no one is electrocuted, or it doesn't cause a hike in the current. Then it says that check appliances before use. Don't buy faulty appliances, right? Then it says that use power bars and multi-plug outlet adapters only when it's necessary. Why does this happen? We learned that overloading can occur due to the hike in voltage. Now think about this. If in one plug you use that extender that you have, right, that extender that you can connect, to which you can connect like 7-8 chargers at once. So think about how much voltage that would actually draw from that one circuit that was only made for one charger, right? So this can cause that hike in the voltage, which can lead to overloading. Okay, then repair or replace any appliance that has damaged wirings or power cables. Why? Damaged wirings, if the wires, live and neutral, they come in contact with each other, it can cause overloading, right? So these are some preventive measures to not, to prevent overloading and short circuiting. Okay, let's move on. So this question says, name 2 safety measures commonly used in electrical circuits and appliances. So this is not talking about what we just studied, switching off the plug or not using an adapter or something. That's not what we're talking about. We're talking about the circuit that we studied. So what were the things that we learned which were as a protection measure in the circuit? The first thing I can remember is the fuse, right? You can write about the fuse, how it's used in series. It has a low melting point. I'm just writing in the form of pointers. You will write proper sentences, okay? Low melting point, right? And Joule's law of heating. You remember Joule's law of heating? What was it? Joule's law of heating is followed. We know that Joule's law of heating said that H is equal to I square RT. What does that mean? It means that when current increases, obviously heat will increase. So if current increases, the heat increases, and because the fuse has a low melting point, so as soon as the heat even increases a little bit, the fuse melts and breaks the circuit and protects the appliance. Second thing was the green wire or earth wire. You remember what was the use of that? It is connected. It connects high current drawing appliances like what? What was the example? Like the fridge or the AC, to a plate, to a metal plate actually, deep inside the earth. So what does that do? If there is any leakage in current, leakage in charges or current, it takes it into the earth, so no one gets an electric shock, right? Okay, great. Let's move on. The next question asks us, an electric oven of 2 kilowatt power rating is operating in a domestic electric circuit, 220 volts. This is the standard in India, we learned, and had a current rating of 5 ampere. What result do you expect and explain? Okay, so again, I'm going to do what I used to do in questions when I used to explain any numerical questions to you. So here, it is actually a mixture of numerical and the logic that you have learned. So we are given that power, we know that power is given to us, and we can also see that it's watts, and we know that the unit of power is watts. Power P is given to me as 2 kilowatts, and we know that this small k sign means that it's 1,000. That means 2 into, in place of this kilo, I can write 1,000 watts, which means 2,000 watts. Okay, the P is given to us. Then I'm given voltage. Voltage is given to me as 220 volts. Now I'm given that it has a rating of 5 ampere. Now what can I see? Do I know any formula that has P and V in it? Think about it. We have used this formula a lot of times. We learned that P is equal to V into I, right? Now, given the P and given the V, let me calculate I. So, my I is equal to P upon V, right? And my P is what? 2,000, and my V is 220, right? This is 11 and this is 100. Now, when you divide this 11 by 100 upon 11, you get 9.09 amperes. But look at the rating that is given to you. It is actually just a 5 ampere rating. So, would the appliance be able to work properly, or would there be any problem? It is a 5 ampere rated appliance and it is getting a current of 9 amperes. What is going to happen? The fuse is going to break, right? What is the fuse there for? The fuse is there to prevent any unduly high current to enter the appliance, and we can see that the appliance needs 5 ampere. So it can take currents up to like 5.5, 5.4, 5.6, 5.7. Once it goes over 6 or near 7, it is very high for it. 9 is too much. The appliance would be damaged. So we write that we can see that the rating of appliance is 5 amperes and current that flows through it in the circuit actually is 9.09 amperes. As this is very high, not normally very high, this is very high compared to the current the appliance needs. This is very high for the appliance. The fuse breaks to prevent short circuit. Okay? Okay, let's move on to the next question now. So the next question asks, what precautions should be taken to avoid overloading of domestic electric circuits? So let me write just 3-4 of the many that were given to you. Okay. So first, I'm going to write the most important thing that I have always heard from my parents is unplug devices when you are not using them. Okay. Then the second thing is, what do we basically want? We don't want the insulation to be worn off so that the live and the neutral wire don't come in contact. Thus, we should not use, or we don't use appliances with insulation worn off. The third point that I can remember is that we don't want a lot of voltage to be drawn from one particular circuit or a socket. Otherwise, it can cause a very high rise in voltage, which can cause overloading. So, what do we not use? We don't use multi-plug adapters. Should be avoided unless absolutely necessary. Okay. So these are the 3 points. You can write any other points that come to your mind. You don't always have to write the ones that I write. Okay, students, so this is all for today's class. We studied about the electric generator, which we used the principle of electromagnetic generation in, electromagnetic induction in. Then we saw how the current electricity reaches your individual houses, and we also solved some questions. Okay, so please, in the next class, come revise with whatever you have done till now, because now we're going to do a quick revision. I'm going to go through the topics in the revision very quickly. I'm not going to explain anything in great detail because I already have. So make sure you come revise with everything, so that when we do a quick revision, everything is brushed up in your mind and you are fresh with all of your concepts. Okay, students, I hope you enjoyed this class. Thank you and take care.